Effect on the physical and chemical properties of the soil. The study was undertaken at the facilities the Colegio de Postgraduados, located in Tabasco, Mexico. The soil with weathered oil was collected within 2 kilometers of the petrochemical La Venta, 18 degrees 0454 N and 94 degrees 0231 inches wide. The pollution-free soil according to NOM 138 Semarnat/SS 2003 was located in the community of Santa Teresa Arroyo Hondo. The objective was to identify the types of soils and their level of similarity. For both soils were determined the content of organic matter, Walkley and Black, pH, potentiometry, P and K exchangeable, by extraction with 1 in ammonium acetate pH 7, quantification by atomic absorption and emission respectively, SEC, extraction 1 in ammonium acetate pH 7, quantification by distillation and titration, and texture, glucose. The analytical methods used were those indicated in NOM 021-2000 RICNAT. Total petroleum hydrocarbons, TPH, were determined by the technique reported in the NOM 138 Semarnat/SS 2003. Effects on plants. Bioassays to determine the phytotoxicity of weathered oil on 2 species of legumes, Crotaluriancain and Lucina leucocephala, were carried out in the facilities of the Laboratory of Soil Microbiology, Colegio de Postgraduados, Tabasco, Mexico. 2 states were studied: phenological, plant and seedling, in 2 treatments, A. Soil with 150 mg/kg 1 TPH, control treatment, and B. Soil with 79.457 mg/kg 1 TPH weathered. This has been contaminated by over 25 years. Both soils were characterized as glycols, with the same phytogenetic origin, as described in the previous section. Bioassays were established under a completely randomized design, CRD, with 3 replications and 2 legumes. These were selected to be species that grow wild in oiled areas, but the former has tolerance, while the second shows sensitivity to high concentrations of crude oil. In each bioassay was used 208 Protocol of the Organization for Economic Cooperation and Development, OECD, modified according to, which allows easily identify the symptoms of stress in the plant. Seedling bioassays, 50 seeds were sown C and Canaan 25 liters. Leucocephalae repetition, respectively. Glass containers were used, 32 by 22 by 5.5 cm. The number of seeds sown per plant species was calculated according to the size of the seed, the viability of the species and the area of the container. Seeds were previously scarified to remove impermeable integument, which constitute a barrier for germination. Scarification consisted of immersing the seeds in sulfuric acid for 15 minutes and washed with tap water subsequent to remove all acid residues. Germination tests were performed to determine the initial seed viability, finding viability standard values in both blocks. The test lasted 30 days and the variables evaluated were mortality, height, root length and dry matter accumulation areal and root. Plant bioassays. Bioassays were established plants seedlings 30 days from uncontaminated soil. Subsequently, 2 of these were transplanted into containers, 15 days after a plant was removed from each container. Exposure of plants to pollutant lasted 150 days to C and Canaan 240 days for L. leucocephala, because of its tolerance respective. The physiological variables were evaluated: height, root length, biomass, leaves and stems, root biomass and number of nodes, leaves and fruits. During both assays was provided with water to field capacity and were not supplied nutrients, N, P and K, to avoid interference on the growth of the specimens. The material was weighed on an analytical balance to obtain the values of DM. The multiple comparison of means was performed by Tukey test, I equals 0.05. The numerical results were analyzed with SAS software version 9.1, using PROC GLM.